Alright, now that I have noticed that my recording was mute until now, we haven't finished any new level for now, so we haven't lost that much. I'm currently considering this function that it's level 15, and our function looks like this. I can zoom out a little bit. This is how many of the function's plot points we know. And we know that the function is like a constant function from 0 to 8, a function that adds 2 to our number from 8 to 15, a function that adds 4 to our number from 16 to 23, and so on. So the idea that we had was to think of our number as, our number is, we check the nearest, where's the thing? Okay, apparently it didn't save, so, okay, now it's back. The nearest number that is a multiple of 8. The nearest smallest number. So for example 252, and we are looking at 248 with 248 equals, let me really quick think, 32 times 8. So this is a multiple of 8, so 248 is the nearest number to that. Then we look at that number and divide it by 4. And if you look at this, it's pretty simple. This one is 32 times 8, so it's basically 64 times 4. So the idea would be that if we type in 252 into our graph, in our function f of x, we should get a number that should be 316. And this means that we have made a small mistake. Okay. And I already think, no, let's think about this. So, first of all, this is an interesting situation. Let's go for a smaller number that we know how to divide by 8. 80. This should be divisible by 8, and it should be 10 times 8. What happens if we type in 80 into a function? 120. This looks like it's a plus 40 increase. So how does this plus 40 come to fruition? This is the current table of things we know. 120 and 180. And oops, that's not a, I have no idea how 80 and 120. Okay, let's go down by 40. The function f of 40, what about that one? 50, okay. 40 and 50. Interesting, an increase of 10. This one had an increase of 40. We have increased this number by 2, and we have increased this number by 4. We have multiplied this number on the left side by 2, and we have multiplied this number on the right side by 2 squared. Is that a hint? Maybe? No, because we have f of 8 equals 10, and f of 40 equals 50, so we have a multiplication on the left side by 5, and a multiplication on the right side by 5. Except if I made a mistake and... no. What happens if we type in 10? It's still 12. What about 41? F of 41, it should be, from my assumptions, it should be 51. What about f of 48? We get an increase of 12. Okay. So f of 48, and we get an increase of 12. If you notice, 48 is a 12 plus 48. 48 divided by 4 is 12. So another assumption that we could have, no, that doesn't work. This one is a fourth of 48. A fourth of 80 is 20, so that shouldn't have, we shouldn't get a number like 120. Interesting. What about 56? F of 56. 70. Okay, so let's type this into our little spreadsheet, I guess. So 56 and 70, a difference of 14. 14 times 4 equals 56, so this also makes sense. But this one doesn't. 80 doesn't make sense. Normally I would have expected this to be a 100. Then it would have perfectly made sense. How about 160? What happens then? I still haven't figured out the function yet. 240. This is a doubling of that. This is doubling that. I don't know. This one I find okay. Let's check out more of the multiples of 8. What about 63? At some point there's something that happens that I'm confused about. Which is why I'm doing 64, not 63, 64. 8 times 8. Okay. 100. And what is the 64 divided by 4? 16. So, no. Right here we have a difference. We have 64 plus 36. And 36 is... 36? Yes, 36. It is not even half, so... I don't know how we get to 36. Okay, right here we have a jump. So what do we have? 0, 1, 2. If you haven't noticed yet, I can graph this thing. And if you look around here, during lower parts of this graph, even lower. How do I do this the best way? Okay, almost right here. During this part of the graph is constant, constantly going up by the same amount. During this graph part, we have an increase of a constant, the increase is increasing, or is increased. So right here at the number, no, it's not the number 8. Okay, this is the number 7, and from 7 to 8, we have an increase like this, and then the graph goes back to normal. Okay. And now we are going back up, back up, back up. From 15 to 16, the same thing. Oh, if I click on this graph, I'm always being ported to Wolfram Alpha, which is a calculated site. But for now, I'm going to check on how this works. This seems pretty normal for now. Right here again. Why does it have to... Whatever. Okay. And we continue. Right here there's something happening. Right here. 47. If you haven't noticed, by the way, I am a little ill. Yeah. Okay. Right here there's something that happened. This increase was bigger. I don't know. Wait 1 second. I have to check. Look up a word. Okay, incline is the word that I was looking for. The incline at those spaces is bigger than the incline between a number that is a multiple of 8 and the number that's directly before that, the natural number, is bigger in this case than the incline before that. 55, 56 for example, however, is different. The incline here is smaller. So we are going to try out the following. We're going to first of all calculate the incline between 8 and between 7 and 8. So right here we have two numbers. So we can simply calculate the incline by m equals 10 minus 7 divided by 8 minus 7. And like that. And this incline equals 3. So we have an incline of 3, okay? Right here we have an incline of 1. Okay. What about here? At 40 and 50. Let's go back and I want to check out 40. We get a 50. 41. We get a 51. We still have m equals 1. Okay. What about 56 and 70? What about 56, 57? 71. Right here. There's something that happened. No, it's not. This is normal. Okay. 56 was 70 and 57 was 71. So we still have m equals 1. Right here too. So nothing too unusual. But something happened that I am confused about. Let's think about this. You know what? We're going to go for another step right here. 39. What happens at 39? F of 39. 47, okay. And we have an increase of m equals 3. Again. Nothing happened, but right here, around here, there's something that happens, but I don't know why it happens. So let's try out 63. 77, okay. 77, and right here we have an increase that's bigger than an increase of 3. Instead we have an increase of 23. But why? Why is that? I did not mistype, right? Yep, I didn't. And now we should empty our little log that we have on this calculator thing. So, okay, what happens now? What happens at 65? 65. 101. We are back to normal incline. Okay. Again, I am a little under the weather, so please do not mind the voice or me muting myself for a quick second or something like that. It's nothing too big. Let's check out just in case the numbers around 80. 81 should be 121, yeah, and 161 should be 241, okay. So the secret lies in between those little increases from 1 being, if rounded down, to a multiple of 8. You're going from one category or one equivalency class to the next one. Interesting. But I haven't quite figured out the pattern yet. So this increase of 3 was constant for a long while until 56 and then 64. 63 to 64. Right here is another multiple of 8, so this might be the thing that happened. 23. Right here we have an... What will be the next one? 8 times 8 times 8? Or should we look at... Let's check out 64 times 2. It should be 120... No, this can't be. It's... No. Also, why did... No, it's not 165, 101, m equals 1. Let's go up to 64, 128 is what I was saying. 128, 127 and 128. I will figure this out. 177 and 200. So we have an increase of 23. Okay. And just for good measure, 129 should be 201. F of 129 should be 201. Yeah, okay. 129, 201. M equals V incline equals 1 again. So we are going to write this differently as a 60. This differently as a 100. M equals 1. So we have here we have an increase of 20 from now on. Let's just quickly check at 80 and 81. No, 79 and 80. 170 and 80 was 100. What? What? 8. That was something interesting. 79, 117. Okay. 80, 120. Okay. Okay, no, it wasn't interesting. I don't know why I thought it was interesting. No, this is just an increase of 3, and this is the typical increase of 3. Okay. Maybe we should check out what about 666, what that number is around. Maybe we don't even have to think too much about the actual formula, but check out how this number works. So 666 equals 400 plus 200, both of them are divisible by 8, plus 40, plus, and what's the rest right now? 440, 640, 26. So 26 can also be written as 24 plus 2. So we can get rid of this one, and 664 is the number that's divisible by 8. So if you figure out what 660, I mean, we don't even have to go this far, so I guess it was a little... Yeah, no, we don't have to go this far. We've already figured out most of the stuff that I needed to know. So every time we have an increase of 64, we increase our number by 23. If we go into the x direction, and we are at the 64th number, from the 63rd to the 64th number, we increase our number by 23 from when going up 1. Every other time when we are at a multiple of 8, we increase our number by 3. What happens at tools? Let's check out what is 8 times 8 times 8. Is that still relevant for us? 512. It isn't relevant for us. Let's just quickly check it out. Way above what we need. Okay. Oh, that was 512. 64. Uh-huh. 10. 4. I think you noticed that, right? This looks like a logarithmic function. What I just saw. What I just saw was if we typed in x and f of x, and x equals 0, 8, 64 and 512, and we get our numbers 0, 10, 100 and 1000. Also not 0 but 1. So this one is logarithm on the base 8 of 1. No, that's wrong. Oh, is it? Yeah, it's wrong. Maybe, wait. So this one is... I'm a little confused right now. This is 8, this is 10, this is... If you haven't noticed yet, this is 10 square, and this was supposed to be 100, is 10 cube. This is 8 cube, and this is 8 square. This is 10 to the power of 1 and 10 to the power of 0, 1 to the power of 0, and 8 to the power of 1. So this, with this we assume we can write every number in the world as x equals every positive number. Let's go for that. The logarithm base 8 of 8 to the power of x, which also equals, due to the logarithm being the inverted function of the exponential, 8 to the number to the logarithm base 8 of our number x. And what we are doing... Did I write this correctly? No, I did not write this correctly, did I? No, I think this is correct. This should be correct. So what our function is doing is, instead of this, we have... Let's quickly check out. So x equals 8, what happens then? Logarithm of 8 to 1. Okay, so first of all, 1 second. Okay, what I was saying is, it's not that we can write our number as this tiled to x. We can do that, but the thing that they are wanting from us is this specific one. This version of writing a number is the important one. 8 to the log of 8 to x of x. At least that's what I think it is. And they are taking this specific... I really can't really describe what I want to say. Okay. If we type in 8 here, then we get 8 to 0. 8 to 0. No, that's not correct. 8 to 0. If we type in 64, we get 8 to... Okay, I think I'm going to write something down and hopefully it's correct. F of x equals 10 to the power of the logarithm base 8 of x plus 1. This is the assumption that I'm making here, and if that is so, then f of x equals 666 is equivalent to 66.6 equals the log 8 base 8 of x plus 1. That's wrong. Not 66.6, but the log base 10 of 666 equals the log base 8 of x time plus 1. So if we rewrite this, then you should get 8 to the power of the log base 10 of 666 minus 1 equals x. So what exactly is that number? Calculator. We need, can this do log? No. So maybe I'm on a completely different path than what I should be doing. I can't even write log, so maybe I'm thinking of this as way too complicated. I really don't know how to do this the best way. I mean, at least this makes sense, I guess, but what's the log 10 of 666? Nothing really. So let's check out the graph again. Right now we have something... Nah, this doesn't look like... This isn't even steady, and this right here should be steady. So I don't know, this doesn't seem like the right way. Back. Okay, let's try out some basic things. Maybe we should just be a little more conservative, try out some functions, and at some point we are pretty close to what we want to have. 420, 500. I mean, I basically already know what the number is that I need. I just typed it in, 400. Let's say 424, and we're pretty close. I just need to go up a few more numbers and I'm there. But the problem is that I don't understand the graph itself. What exactly am I doing wrong? I understand. Let's go back to this version. No, this was the correct idea. The idea was correct. If I have a potency of 8, then it's going to be converted to a potency of 10. This is what the function gave to me. However, I don't think this can be that complicated. I'm going to quickly enlarge this little window in the hopes of the calculator giving us the opportunity to... No, we still can't use log. Okay, so we really weren't supposed to do something with log. I am still curious, so I am going to try it out. Not like that, around... maybe like that. Okay, I'm going to go to Wolfram Alpha and I'm going to write down the function that I have had an idea for. If that is the correct function, I guess I'm glad. If not, then we have to try something else. Nah, this isn't the function. Definitely not the function. If I get rid of one thing... Nope, so this is not the function. Maybe I'm making a rudimentary mistake, I don't know. I don't know. So we have from 8 to 10. I really don't know. How could we... I mean, this version probably won't work for what I'm going for. This isn't the thing that we're looking for then. We should be looking for this one. Doesn't make it better, but we can at least try the following. So, 666, we are going to divide it by 64. I'm going to do this right here. 666 divided by 64. What do we get? 10.40625. Basically, this means 666 can be expressed as 10 times 64, which is 640, plus 24. So by this calculation, we get 20 times 10 plus 8 times, what was 3 and 83 equals 200 plus. This is too big a number, is it? It is too big a number. 649. Yeah, okay, I get the problem, yeah. What am I doing right now? Right now, I am looking for a way to express 666. We know how a function behaves. We already have figured out that part. We have figured out that every time we increase our function's x component to something that is higher than the next biggest multiple of 8, we increase our function's increase is increased by 2. So our function adds 2 more to our basic number than it did before. So that is what we know, and we also know each time we increase our number by a multiple of 64, our function increases 20 of what our number of 20 to whatever it was increasing before, plus an additional no, that's basically the 20. What exactly does that mean? I'm making one crucial mistake right here, but I don't quite see it. So it increases 20 plus an additional 2 to what it increases, because it is a multiple of 64 is a multiple of 8, so it increases because this number is a multiple of 8, and because it's a multiple of 64. That's the idea. So the idea that comes next would be expressing 666 as a number x plus a number k times 64 plus a number k times 2 plus a number L times 8. That should be the equation. However, this thing has a lot of, right here, x, k and L, those are 3 variables. One way to solve this is definitely by just, you know, going through the numbers. But I don't think that this is what they want us to do. At least that would be a little too boring, I'd say. You know, I might check out the hint. Okay, this doesn't say anything. Okay. Oh wait, right here. Hint. The function converts decimal to base 8. What decimal number is 666 and base 8? Well, I tried that, but that didn't work. I mean, 666 equals 512 plus 154 plus, no, equals 512 plus 64 times 2, which is 128, plus, what's left? 128. We still have left 626 equals 512 plus 2 times 64 plus 3 times 8 plus 2, which would be 1, 2, 3, 2. 1, 2, 3, 2. I'm really... No more guides, no more guides. I did not want to check that out. I mean, I've already noticed this thing where it converts 8s to decimals, but maybe I'm thinking of this wrong. Maybe 666 is meant to be 6 plus 8 times 6 plus 64 times 6, maybe. What is that? 6 plus 48 plus 360 plus 24. This equals 54 plus 360 plus 24. This equals 414 plus 24. And this should equal 438. God damn it. I'm going to say this is the fault of me being a little ill. That's the fault. I'm feeling under the weather. That's the fault of that. And I think I even saw this one being solved by Aliens Rock, the YouTuber that I saw this from. Quite annoying. Whatever. We're going to go for 20. No matter how long it takes, we're going to go for level 20. So we know that our next number has an output of 0 at 0. We already know this function, right? At 3 it should be an 80, minus 80. At 6 it should be minus 18. Yeah, it's okay. This one is pretty simple. It was f of x equals, we have a division of the number being odd or even. If a number is, what did I write in? X even. Then we have minus 3 times x, and otherwise we have minus 83 plus x, I think. Alright. This is going to be, I think, a lot easier than the thing we did last time. X odd. And now we're just going to check out f of x equals 666. And we're going to say x is even. Then we get minus 3 times x equals 666. This would mean x equals minus 222. this, we're going to try this again. F of x equals minus 222. I can still assume that x is even. That means we know x equals 222 divided by 3, which, what is that? 70, 77, not 77, 74 maybe? 74. We can still not do this thing with 74, so we're going to try XOR. F of x equals 74, which means it equals minus 83 plus x, which means x equals 157. We can't do that one. Again, we need to go for XOR. We can just continue this however long we do this. There's a more efficient variant by doing this in a tree form. We could, right now I'm doing the following, in a graphical sense. We have a number 666, and there's always two paths going down from that number. There's the one where our solution x is even, and there's the one where it's odd. X even, x odd, and we can do that for most numbers. Even though not all of them have two solutions, we can at least try. So the most logical thing would be doing this in a going into the width of the tree instead of what I'm doing. I am doing the following. I am just going straight down. So this is what my version looks like. I'm just going to take the one that I get, and I'm just continuing from there. It's a little more inefficient. Maybe it's not even that inefficient, but it's a little more less thinking. Also, I'm going to delete that because I don't want to have that much space used. But it's just simpler. No need to think. And I always know whether this has an even solution by looking at this number, and if it's divisible by 3, you know that if you add the partial numbers 7, 5 and 1 together, 13, if this is divisible by 3, it is not, then the whole number would have been divisible by 3. So 1 on 70 is 57, x equals minus 83 plus x. So this means x equals 240, I'd say. 240 is also not possible, however this thing can be divided by x even, by 3, and if x even, this has a solution. X even and f of x equals 240. This means x equals minus 80, and now we just have to, okay, 1 f of x, 2 f of x, 3 f of x, 4 f of x, 5 f of x, 6 f of x, and we need 6 f of x, and then we need to input the number minus 80. 5, 6, and nope. How do you do it again? There's a way to write this down. Okay, 1, 2, 3, 4, 5, 6. God damn it. Maybe I did a mistake. What happens? Okay, first of all, let's check out minus 80 by itself. What happens? We get 240. And what happens if we can't write that down? Okay. What happens like this? Minus 80. How do I write this the best way? 80 minus... Okay. We get minus 720. That's weird. Oh, because this one, even though it's odd, it doesn't have a solution, since 240 is not odd. Okay. So we can't go that route. Okay. I'm still going to keep it written down. And we're going to need to write a big spreadsheet like this, I think. 666. When there's an odd solution and an even solution, let's start off with this even solution, minus 222. And the other one I haven't calculated in this run, so let's go for 666 equals minus 83 plus x, and this is equivalent to x equaling 740, I think, 749. 749, we will need to do this in a tree fashion. What a pity. Okay. And, oh, this is also important. Yeah, no, this is still correct. If x is even, then minus 774 is a solution for this thing. 74. And the odd solution would have been f of x equals minus 222 equals minus 83 plus x, which is equivalent to x equaling 305, which still fits the scheme. 749 has no even solution. Wait, 11, 20. This doesn't have an even solution, so I'm going to say NA. I think this is an abbreviation for no solution, but I don't know what it specifically stands for. I mean, I can look that up. NA. In Germany, it means no. It's a. Okay, no answer. Okay, it means no answer. Okay, and the odd solution of this thing, what's the odd solution? F of x equals 749 equals minus 83 plus x, which is equivalent to 820, 832 equaling x. So 832. Okay. Okay. Still nothing that is divisible by 3 on this one. So right now we still have 3 solutions to work with. 74, we've already tried one method of having this be have an odd solution. 74 does not have an even solution because it's not divisible by 3. So from now on we need to make a lot of space. I hope this is going to still be working in a smart way. Whatever. 74 does not have a good solution, an even solution, so let's try out the non-even solution, which the idea of non-even is odd, so 74 equals minus 83 plus x, which means that x is equal to 9, I'd say. And if we do this, 9, 9. Okay, thank you. That solves the question. Also, I made a small mistake right here. Okay, yeah. 222 minus 74 and then minus 9. Okay. I think that's, yeah. This is what I actually calculated. Whatever, it worked, so we're not going to say anything. 1, okay, 8, 4, 14, and 7, 20. Okay. 1, 8, 4, 14, 7, 20. So right here we have an increase of 3 on the x scale and 6 on the y scale. Here we have an increase of 3 on the x scale and 6 on the y scale. So the first idea would be f of x equals b plus 6, no, what did I say? 3, 6, 2x. What is b? We can solve that by having f of x, f of 1 equaling, what was it, 8? Equals 2 plus b, which is equivalent to b equaling 6. And that would mean, yeah, okay, we now have a solid function. That's probably correct, let's be honest, but I don't know, and let's really be honest, it now depends on what happens if you, for example, type in 44. Normally this function should give out 96, 94 or something. Okay, this is working. So this thing, we can graph it if we want to, it's a linear function. This makes things a lot easier. We just go for f of x equals 666 equals 2x plus 6, and we know that this means that x equals 330. We do this again. Equals 330 equals 2x plus 6, equivalent to x equals 324, 112. Still can't do it. F of x equals 112. I'm doing all those things right now in my head, so it's just quick calculating. Nothing too special, at least if it's correct. If it's not correct, then I mean it really isn't anything too special, but hey, let's try it. 112, 106 divided by half, divided by 2, 53. 53, we still can't do anything with that. 53 equals 2x plus 6 equals 47, 23.5. Okay. This isn't looking too good. Now the next ones are going to be have a 0.25 ending, which is not what we want to see. Next a 0.125 ending, which is still not what we want to see. Next is a 0.0625 ending, and I don't think that this is a correct way of doing this. What happens with negative numbers? Let's quickly check out negative numbers. Minus 12. 24, 36, 18. Nope, this is the same thing that happens with positive numbers. Okay. What? I didn't want to save this. Whatever. Okay, whatever. Nope, I don't want to go to Wolfram. I wanted to check out the graph, but apparently it's not an option right here. Or maybe I need to input some graph things. No? Okay. So how do we do this? I mean, if we continue, we are not making any progress because the 2 and the 5 are being blocked. Can I do anything like 9 plus 6? No? Okay. Let's check out at high numbers. How does this work? Okay. Let's go for 471. Okay. So it looks like we have been on the right track. So 330 doesn't work, 112 doesn't work, 53 doesn't work. Let's try out, instead of this, let's try out minus 666 and let's try that. Maybe it's a little easier, or maybe a little faster, or maybe it's even possible. That would be pretty nice. Let's try this entire thing once more. Minus 666, 2x plus 6, and this means x equals, I'm going to here shorten the mathematical correctness, which already isn't that high here, because I'm pretty lazy. Minus 672 minus 336, okay, 336, we still can't use it. F of x minus 336, 2x plus 6, x equals minus 342 minus 2, 342 I said, 100 minus 342 divided by 2, which equals 150, 171 minus 171. Okay, yeah, we can work with that. 171 minus minus. Okay. Another story thing. I really don't care about the story. I really just care about the game. So let's try. We have a new symbol. Alright, we need to use this one. I think I saw this one. I did spoil myself a lot, but don't worry, I didn't remember the solutions. 0, 0. A binary function. Psi is a binary function that forks two numerical inputs. So what did I make a mistake with when I... Okay. Well, I don't care. We know something. How should I start them? 0, 2 works. 0, 2 is 0. 2, 0 is infinity. And 0, 2 was 0. Okay. So we have x, y, and f of x, y. 0, 0 doesn't make any sense. Not defined. AKA 0 divided by 0. I already have an idea of what the function is, just so you know. That wasn't a hard one. Also, I don't think that I've seen this one. I have mostly scrolled through the ending parts of this one. So 0, 2 is 0, aka 0 divided by 2, and 2, 0 is infinity, aka 2 divided by 0. So the logical conclusion should be me checking whether the recording's still working, because it's been a while, and the function should be f of xy equals which one over which one? X divided by y. Which in that case, let's go for we do now need to find two values which together equal 666. Let's check out for some multiples of 666. 666, 2, 3, 3, 1 is another times 1. You know what, I'm going to do this the following. I'm just going to use multiples of 2 by doing this, because that doesn't work. Okay, we're just going to continue like I wanted to. I don't know what I wanted. Let's just continue. So 8, 9, 9, 1. Let's go for the next one. 4, 6, 6, 8. And now we have something. Okay. Which way do we write this? No. 8, 6, 6, 4, and 4. Did I make a miscalculation? So first of all, this should be 4 times 666. So what I thought would happen is if I write this down. How did I? What? 2. Yeah. Let's try this again. 2, 6, 6, 4, and 4. Okay. Again, I'm a little under the weather, feeling under the weather. So 0, 0 this time. Let's try it again. 0. Okay. We have a more cute function. Okay. How about 0, 3? Okay, still 0. How about 3, 0? Still 0. Okay. How about 3, 3? Minus 9. 3, 3, minus 9. Okay, I think we can already do this. No, 222 doesn't work, 111 doesn't work. We didn't want to make it too easy. I can't do 0.5, damn it. Okay, so the idea is probably going to be f of x dot y equals either minus x times y or something along those lines. We're going to try a little bit out. Minus 3 psi minus 3 should be minus 9, also correct. Minus 3 psi 3 should be 9, also correct. Minus 3 times minus 3 should be 9. Okay, so this is the correct assumption for now. So we need to find out a multiple of 666. No, a factor of 666, which is 3 times 2 times 111 equals 3 times 2 times, how do you factor 111? 3 times 37, I think. And all those other factors. So 6, 18, we can't go for 18, but we can go for 6. What about with 37? 3 times 37 was 111, which we can't use. We just need to... Okay, we can just do this. We can just do this. 3 times 2. We can't do the 2. Well, we're going to do the following. We're going to type in 6 times 3 times 37, and we have a correct number. Please rate and review. I think... no. Not for now. I'm only at level 20. Like unary functions, Psi can perform abstract non- or semi-algebraic operators. We're doing this one last, and then we're going to stop. 0, 0. Okay. 0, 1. Okay. 0, 1, 0. Okay, 1, 1. 1, 0. Okay. Let's type in all the data sets we now have. 0, 0 is still 0. 0, 1 is 2. 1, 1 is 22. What about 1, 0 is 20. Okay. Okay. So for now my assumption is the number on the right, f of x, y, equals 2 times x concocted with, I think it's called concocted, combined with 2 times x combined with 2 times y. If that were the case, then f of 10 dash 10, not dash, 10 and 10, f of 10 and 10, it should be 2020. So 10, 10, okay. Then in that case, 3, 33, and we have all 66. Okay. And for now, I think this is the end of today's video, which is 58 minutes. This took a while, but hey, it's fine. Just a relaxing thing. And for now, have a nice day. Lastly, right here, if you're ever... no, not this one. If you're ever interested in looking, I have this now. From time to time I will let this fade in, and goodbye.